Alright, so we are jumping into section 4.4 today. So we finished up 4.3 yesterday talking about exponential functions. Now we're going to kind of jump into something that is very similar to that. I think this is something you guys saw back in Alpha 2. We're going to be looking at logarithmic functions here today. Now, as you can see in this first sentence, a logarithmic function is the inverse. We have been talking about inverses a little bit more in this chapter. As we take an x and a y and flip them, solve for y to the y by itself. Now, a logarithmic function is the inverse of an exponential function. Alright, so if I were to take this functional equation of y equals a to the x, that would be the inverse. Again, flip your x and your y, solve to get y by itself. Alright, so that is going to look like a logarithmic function. The way you take an inverse of exponential is by doing a logarithmic function. Alright, so if you look down here, this is kind of an example of what we're going to be looking at. This is really the premise of what we're doing in this whole section. A logarithmic function to the base a. So right here, guys, this is what we're going to be looking at as kind of our base or parent function of the logarithm. Alright, so it's read y equals log base a of x. And so the same base a is going to help you because the base a here is also going to be the same base in my exponential. Alright, so that base a and this base a and my log are the same thing. So saying log base a of x is going to help you. Alright, now, I kind of have a little way that I like to convert. Alright, so the base of your log is going to become, let me call it this, the base of your log base a, is going to be the base of your exponent. So we're going to convert back and forth from logarithmic to exponential, from exponential back to logarithmic. But your base is the same. Log base a, x equals base a raised to the y. So I'm going to take my logarithm and convert it to an exponential. So log base a raised to the y power, and I call this kind of the around the world method. Log base a raised to the y power equals x. I'm going to call around the world, take the 4 seconds, going around the world. So log base a of y equals x. So we're going to write that down. So again, around the world activity. So first we're going to yellow. Alright, so log base a of y. Alright, so log base a of y, that's the first thing we're going to do. And the second thing is equal to x. So log base a raised to the y power equals x. So that's kind of my around the world activity. And similarly, guys, over here, if I was going to convert this exponential into a logarithm, it would be log base a of x equals y. So that would be converting it back to a logarithm. So once again, log base a of x equals y. Alright, so we're going to look at a few examples here, just converting back and forth. So hopefully this will kind of help clear some things up. So look at this first. Change the logarithmic expression to an equivalent expression involving an exponent, aka convert this logarithm, number 1, convert this to an exponential. Alright, so I'm going to do my around the world because that's what I do and that's how I know it. So it's log base 3. So it's going to be base 3 raised to the y value, 3 raised to the y equals x. So there you go. I converted my logarithm to an exponential. So again, 3 raised to the x power equals x. So 3 raised to the y power equals x. Not bad enough. Alright? So let's look at another one. Same thing like that. So it's log base a of 3 equals 6. Now, they kind of move some things around, but that's fine. It's still the same thing. So instead of going this way, I'm just going to take that and go this way. So it's log base a raised to the 6th power. So a raised to the 6th power equals 3. So again, the base of your logarithm is going to be the same as the base of your exponential. So it's log base a of 6 equals 3. Alright, so that's going to be converting it from a logarithm to an exponential. So now let's take it and go backwards now. So now let's look at some exponentials and let's convert them to logarithms. So change the exponential expression to an equivalent expression of a logarithm. aka change it into logarithmic form. Alright, so that's just kind of some of the word that you're probably going to see. That's why it's written that way. But this is means changing the logarithmic form. Alright, so I've got base A raised to the fourth equals 24. So I know this is going to be log base A. So same thing. We are going to do my around the world. That's how I know it. So log of base A of 24. So log base A of 24 equals 4. So log base A of 24 equals 4. And then you can go back and always double check just to make sure. Same exponential. A raised to the fourth power equals 24. So it's the same thing. So you can always go back and check your work that way. 2 factorial. Alright, so there you go. That's my logarithmic form. If you don't like the around the world, that's fine, guys. Just make sure you remember how to do that. I like it because it's just kind of cyclical memorization. Alright, so same thing here. Let's look at number 4. X raised, and that's actually the square root of 2. That's the square root of 2 equals pi. So once again, change it to exponential. So I know this is going to be, x is going to be my base. So it's log base x. Alright, so log base x of pi equals square root of 2. So log base x of pi equals square root of 2. Nice little cycle. It's a circle around here. A curve matata. So there we go. Now let's look at the calculator. We're going to solve without using the calculator because you don't need a calculator. Right? And the way we're going to do this is I'm going to set my equation, my log base 6 of 6. I'm going to set that equal to x and solve. Because what I'm going to do is after I log curve, I'm trying to solve it. Typically, what you're going to want to do is convert it to an exponential and solve it that way. Alright, so we look at this. Log base 6 of 6, I added in the equals exponent, so I'm going to solve for something. Alright, so let's convert this to an exponential. So if I were to do that, it's going to be 6 raised to the x power equals 6. Now 6 is the 6 to the first. Now, if you go back and remember what we just did yesterday, the day before, with exponentials, if I had a common base, it's probably the best way to use it here. If I had a common base, I can set my exponents equal to each other. So x equals boom. And what you guys will eventually realize too is anytime you're taking the log with the base, and you're taking the log of that number as well, so if the base and the number you're taking the log of, if those are the same, it's always going to be one. Alright, so it's kind of something you can work with. Alright? So let's look at the second one. Alright, so once again, I got log base 4, that's up 1/16. Alright, so once again, I'm going to set that equal to x, and I'm going to solve. Alright, but the best way and the easiest way to solve is to take this logarithmic and convert it into exponential, and vice versa. If you have an exponential trying to solve it, sometimes it's easier to put it to logarithmic form. Alright, so let's rewrite this in exponential form. So we have log base 4. So I know my base of my exponent is going to be 4. So it's going to be 4 raised to the x power equals 1/16. Now this should look pretty similar to what we've been doing with our exponential function when we're simplifying and solving. Alright, so let's find a common base. Alright, now the common base between 4 and 16 is going to be 4. Alright, so 4 to the x, it's already there, so it's going to bring that down. 16, I'm going to rewrite as 1 over, so 1 over 16, I'm going to rewrite as 1 over 16 rewritten as 4 squared. So it's 1 over 4 squared. So once again, I haven't changed any values. I have just converted it to a lower base. Alright, so like we talked about before, the easiest way to do this is to move that denominator up to my numerator. When I do that, it's going to make my exponent negative. So this is 4 raised to the x equals 4 to the negative 2. Because we're going to move from the denominator to the numerator, so we're equal now. Or that makes my exponent negative. So now, once again, same base, set my exponents equal to each other. So I'm going to have x equals -2. Boom. It's good stuff. Hopefully this stuff isn't too bad for you guys, too difficult. Alright? Look at some others. base 1/2 of 16. Now I want you guys to take a quick second. We're actually not going to do number 8. All right, I want you guys to take a quick second, see if you can solve number 7. Alright, so let's look at this one. Log base 1/9 of 16. I'm trying to simplify that without using a calculator. So I'm going to set it equal to x, and we're going to convert it to an exponential. It's just the easiest way to do it. Alright, so I'm going to have a base of 1/2. So I've got a base of 1/2 raised to the x power equals 16. So log base 1/2 of x equals 16. Alright, now, this is 2 to the first in my denominator, so what's going to probably be easiest when you have a fraction is to try and get that base into the numerator. So, just like last problem, to move that base up into my numerator, I'm going to make my exponent negative. So this will become 2 to the negative first power raised to the x equals 16. Alright? Laws of exponents. A power raised to a power means you multiply. So negative 1 times x is negative x. This is 2 raised to the negative x equals 16. Now, I'm actually, before we do that, I'm going to take 16, I'm going to rewrite that as a base of 2 as well. 16 can be rewritten as well. 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. I'm going to rewrite that as 2 to the 4th. Alright, so, on base, set your exponents equal to each other. So I've got negative x equals 4. I'm actually going to divide by negative 1 on both sides, so I'm going to get x equals negative 1. There you go. Boom. Awesome. Awesome. Alright. Now let's make this, let's take it the next step, of course. You guys were wondering how it's going to get more difficult, but it doesn't get too much more difficult. We just want to go through and solve them. So I've got a logarithmic equation. Typically, the easiest way to solve a logarithmic equation, like we just talked about, is to convert it to an exponential. Alright, so I'm going to convert my logarithm, log base 3 of 4x minus 7 equals 2. So let's convert that to an exponential. Alright, so first, log base 3 means my exponent's going to have a base of 3. So 3 raised to the second power of 3 squared equals 4x minus 7. Well, it's 3 squared. Pretty good. That would be a 9. So I've got 9 equals 4x minus 7. Becomes your basic algebra problem now. Add the 7 over. 9 plus 7, well, that gives you 16 here. So 16 equals 4x. Divide by 4, you're going to get x equals 4. And there you go. Awesome. Awesome. I think that might be a little wrong. So it is. Alright, so let's look at another one, guys. Similar type problem. Alright, so the other ones before I do it out of calculator, I can still do this without a calculator as well. Alright, so I've got a logarithmic equation, I want to solve it. So typically the easiest way to do that is convert to an exponential. So I've got log base x of 2, or x raised to the second power, equals 64. X squared equals 64. Well, the way I solve it, I am going to take the square root of both sides. Alright, square root of 64. Please, please, please don't say 8. What is the square root of 64? Very good. I know somebody said something. It's plus or minus 8. Make sure you include that plus or minus. Otherwise, you're wrong. Make sure you include it. Alright? So, that's another example for a logarithmic equation. Let's keep going. That sounds like a super idea. Alright, so, same thing. Got a log. I want to solve it. Make it exponential. I'm going to have my base of x. I'm going to raise it to the third power equals 1/8. So x cubed equals 1/8. Alright? Now, just a little sidebar. We're going to go right over to the right of my equation. Alright, let's just say this was x cubed equals 1, or just 8. X cubed equals 8. Alright? Just like if that was x squared equals 16, I take the square root of both sides. This is x cubed equals 8. So to get x by itself, what I want to do is take the cube root of both sides. Alright, so I'm looking for a number that when you multiply by itself 3 times, you get 8. The cube root of 8 is actually 2. 2 times 2 times 2 gives you 8. 2 squared is 4, 2 cubed is 8. So the cube root of 8 is 2. So I can do the exact same thing over here. Alright, x cubed, I'm going to take the cube root on both sides. So that gives me, I'm left with x. Now, just like if this was a cube root of positive 8, it would be 2. The cube root of 1/8 is going to be 1/2. The cube root of 1 is 1. The cube root of 8 is 2. So that's 1/2. It's good stuff. I know you guys are thrilled right now. Alright? Alright, let's take it another notch. Alright, so same thing. We got a logarithmic equation. Let's convert it to an exponential. Log base 3, which my exponent's going to have a base of 3, raised to the 2x plus 1 power equals 243. Alright? Now, can't really solve that because my x value is in my exponent. So what I'm going to do is I'm going to get a common base here, so that way I can set my exponent equal. So somehow I'm going to take 243 and rewrite it using a base of 3. Now, the 3 is already at a base of 3. That can't be manipulated out. But 243, so 3 times itself, how many times gives you 243? Well, 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. So what about 3 to the 5th? That would be 243. So 243 can be rewritten as 3 to the 5th power. Alright? So now I've got my same base. Now I can set my exponents equal to each other. Yes. Yes. So 2x plus 1 equals 5 or 5. Alright, so it becomes your basic algebra. Subtract 1 over. I get 2x equals 4 or 4 divided by 2. 4 divided by 2 that's 2. There you go. That's all, folks. Alright? Any questions so far? I don't see any hand raised because we're not in there. So there you go. Alright? This is, well, then we'll get down to the final few problems. Alright, so let's give you guys a second. I want you guys to try this one. Yeah. Alright, same thing. And then logarithmic, I want to convert it to an exponential so I can solve. So let's do that. Alright, so log base 3. Alright, so that means my exponent's going to have a base of 3, so it's going to be 3 raised to the 2nd power equals x squared plus 1. Alright, so 3 squared is 9 equals x squared plus 1. Let's subtract the 1 over. 9 minus 1, well, that's 8 last time I checked. So I got x squared equals 8. So last thing we need to do is take the square root of both sides. We're going to do it. And boom. Now the square root of 8, that's 8 is not a perfect square, so we'll simplify this. I've got x equals plus or minus, don't forget, when you take the square root, plus or minus square root of 8. Now, what's the largest perfect square that you can take out of 8? Very good. That's 4. So I'm going to rewrite that as the square root of 4 times the square root of 2, because 4 times 2 is 8. Alright, square root of 4 is 2. So it's going to be plus or minus 2. Square root of 2. Boom. How's that for now? Cool. Any questions? Alright, I think we're getting down here. This is the last one. Alright, so once again, guys, let's do this. Log base 2. Change it to an exponential, so it's going to be the exponential with a base of 2 raised to the negative 3 power equals 8 raised to the x. Alright, just like we're doing exponentials, it's time to get a common base. Alright, the common base between 2 and 8 is going to be 2. So bring down my 2 to the negative 3. 8 I can rewrite as 2 cubed raised to the x. Alright, once again, I got a power raised to a power, and multiply them. So I've got 2 to the negative 3 equals 2 raised to the 3x. Setting base, set your exponents equal to each other. So negative 3 equals 3x. To get x by itself, let's divide both sides by 3. I'm going to hit x equals negative. Alright, so guys, that's section 4.4. Alright, there's really not much to it except for just introducing yourself to logarithms. Hopefully some of that looks familiar to what it was last year, but just algebra 2. Alright, but the homework assignment's right there. It's also on the website. It's a few programs. It is some of them will not take you very long to. But there you go. It's Friday. I hope you guys have a wonderful weekend. And we will see you guys back on Monday.